Hello everyone. We discussed in the previous lecture about flow networks and Ford-Fulkerson's algorithm for finding maximum value. And as we already know that what is the flow, what is the capacity, what is a flow network, and what is a residual graph, uh, we already know. We did that in the previous lecture. Those who have not watched the previous lecture for flow networks, I would recommend you to watch that lecture before continuing discussion in this lecture. This is going to be very short discussion. I would have done that with the previous lecture, but nevertheless. So as we already know that the Ford Fulkerson's method, we call it a method basically. So what it does that it it finds a path. Okay, it finds a path from source to destination in our flow graph. Okay, in residual flow graph to be precisely, and the complexity was in the order of v plus e, and the final complexity asymptotic value to find the maximum flow value is in the order of edges multiplied by whatever is the maximum flow value in that order. So it's sort of is there any way we can have a bound on the complexity, or we can reduce the complexity value? Because see, for example, if f is maximum flow value is 1,000,000, then think about it will have to do million operations. Okay, now Edmonds and Karp, these scientists, they came up with a novel idea that instead of choosing a path, just any path at step number 3 in original Ford's algorithm, what if we use breadth first search and choose this shortest path which has some available capacity left? So we can find the maximum flow value faster and in the order of v multiplied by e square, and that was a brilliant idea. So essential difference between these two algorithms is the way how the graph search is being implemented. So if you're going to use breadth first search and you're going to select shortest path at each iteration in the while loop at line number 3, we would say it's the Edmonds-Karp algorithm. Other things are same. There is no change. You can execute these steps on sample graph. Nevertheless, it is very similar to what we discussed in the previous lecture. So this was a short discussion on Edmonds-Karp algorithm. Thank you very much for liking and subscribing LeProfesseur on YouTube. Those who have not subscribed, please subscribe, and if you like the video, do not forget to give hands up. Have a wonderful day.